Hi, John here. In this video we're going to look at a turbocharger. We're going to look at all of the turbocharger's main components. We're going to look at how it functions. Then we'll look at why you would have a turbocharger installed, and we'll discuss concepts such as turbo lag. So here we have a 4-stroke V6 engine, and on the back of the 6-cylinder engine we have a turbocharger. So this is the turbocharger. You can see it in the center of the screen now. The turbocharger looks slightly like a snail, and if we view it from the other side. So the reason that I'm showing you this is because if you ever see a turbocharger, or if you're looking at an engine, you'll be able to identify it. You'll also be able to identify it because it's connected to two separate systems, the air system and the exhaust system. So let's now have a look at the turbocharger and all of its components, and then we'll discuss how it works. So again, here is a more detailed model of a turbocharger. You can see the different sides, and now you can also see some of the interior components. You can see some of the outer casing, and on the opposite side as well. So let's break this down into its components, and we can then have a look at how it functions. There you go, I've exploded the model. At this end, this is the end that connects to the air system, and this is what's called a volute casing. You'll often see the same shape on centrifugal pumps, and it's this snail-like shape here. And we can see that the inlet is through the center, the same as for centrifugal pumps, and the discharge is out of this pipe here. We've got our outlet here, and we've got our inlet, and this connects to the air system. We've then got a compressor wheel, that's this item here. And then past that, we've got a plate. And further down we've got what they call a central hub rotating assembly. And it looks like a couple of bearings here. A shaft. It's the shaft coming all the way through. This item here is our turbine. And then we've got the casing again. So let's just assemble that again, and we'll talk about the systems that it's connected to. So on the left hand side, as previously mentioned, this side here connects to the air system. This is drawing air into the engine, and we're going to use that air for combustion because it contains oxygen. Look on the other side, we've got a turbine. This is a gas turbine, and what we're going to do, we're going to pass exhaust gas over the turbine, and we are going to cause the turbine to rotate. And this turbine is connected on a common shaft to the compressor. So turbine on the exhaust gas side of the engine. So there's exhaust gas coming from the engine here and going to the turbine. If we go on the opposite side, we've got compressed air going to a compressor, and that is connected on a common shaft to the turbine. So, as you might have realised, if the main driver for the turbocharger is the turbine, which it is, then as the turbine turns, it's also going to turn the compressor. Now it's important to realise this because as the turbine turns or increases or decreases speed, it's going to turn the compressor wheel because it's on a common shaft. So keep that in mind. What I'm going to do now is switch to another model, and I'm going to tell you exactly what the turbocharger does. So here we are, this is our turbocharger, and this is the system where it would be installed. We saw where it was on the engine earlier, but now what you're actually seeing is just the air system and the exhaust gas system. You can see, in fact, let's just start by the turbocharger. We have our turbocharger, although it's slightly rusty, and then we can see there's some piping. We have an aftercooler. And then we have our combustion chamber and our piston And we can see also that there's some red and blue arrows. The red arrows symbolize the exhaust gas. So we can see here that there's some red arrows. And the blue arrows symbolize compressed air. So let's walk through the system now, and I'll explain to you exactly how the whole thing works. So our engine is running, and we've got some exhaust gas coming out and going into the turbocharger on the exhaust gas side. So, in fact, let's go to our cylinder because that's where the exhaust gas will come from. So here we go. The exhaust gas is coming out here, and if these valves are open, we've got two exhaust valves. There is one, two, these two exhaust valves, two compressed air valves. These are air inlet valves on the left, exhaust gas on the right. When these open, the exhaust gas is going to pass out of the cylinder or the combustion space, and then it's going to go, you just zoom out here, along this pipe, along here, along here, along here, and it's going to go to our turbocharger. So the exhaust gas going to the turbocharger. As it passes over the exhaust gas turbine, it's going to cause this turbine to rotate. Now, the turbine is connected on a common shaft to the compressor wheel. So now the exhaust gas is going to leave the engine. It's done its work, and we're going to have a look at what happens to the compressor wheel. Remember, it's connected on the common shaft. So over we go, past the central hub rotating assembly. Here is the compressor. That is now also turning because exhaust gas is coming out of the engine and passing over the turbine. So it's turning, it's drawing air in, and this air is then going to be compressed. That's why we call it a compressor wheel. It's going to compress the air. We compress the air and then we'll discharge it to the volute casing. This casing is actually designed so that the velocity will drop and the pressure will increase. That's what a volute casing does. So the air velocity is going to drop, the pressure is going to increase, and then it's going to be discharged along this pipe, along here. We're going to cool the air down. I'll tell you the reason for that in a moment. We're going to cool the air down in the aftercooler, and then we're going to go along here, and into our cylinder again, or into our combustion space. Should call it a cylinder liner rather than just cylinder, but I think you understand what I mean. So it's going to come in then through these two valves when they open. So now we know what it's doing, let's discuss why it's doing what it's doing. Well, the exhaust gas is just a waste product. So any energy that we can get from the exhaust gas before we discharge it to atmosphere would be a bonus. Now with a diesel engine, you can actually get more power from the engine if you compress the air and get more oxygen into the combustion space. If we can add more oxygen to the combustion space, then we can add more fuel. If we add more fuel, then we can create more power, or at least we can transfer more power to our load. Now our load may be an emergency generator, it may be a truck, it may be a pump, it doesn't matter, but if we add more fuel, then we need to add more oxygen. The turbocharger allows us to add more oxygen in the same volumetric space. So let's have a look at the combustion space. You can see here that the space is limited. We're only ever going to be able to work within the confines of the combustion space. So that's going to be a maximum where the piston moves down the bottom dead center, all the way up until the top of the cylinder liner. So if we want to create more power, then we could just put more fuel in. The problem is we don't have enough oxygen. In order to get efficient combustion, you need to have all the elements of a fire triangle. That means oxygen, heat, and fuel. Now the oxygen is supplied from the ambient air. The fuel is delivered from our fuel system and our fuel injector, which we can see at the top here. And the heat is supplied as the piston moves up the cylinder liner and compresses the gas, or in this case the air. So we've got heat because we're getting that when we compress the air within the combustion space. We've got the fuel, but we need the oxygen. So if we want to increase the power, we've got to deal with all of these elements of the fire triangle. Now we know that we can just add more fuel, that's not a big deal. We can't really add more heat, but there is enough heat there because we're compressing all of the air within the combustion space. How are we going to get more oxygen into the combustion space in order that we can generate more power? Well, that's where the turbocharger comes in. The exhaust gas drives the turbine, and that drives the compressor wheel. As we compress the air, we're also increasing the amount of oxygen that is packed into the combustion space. So in other words, we're increasing the density. There's going to be more oxygen within the combustion space. But we can go even further. Not only have we compressed the air in order that we can get more oxygen into the combustion space, you can see we're also cooling the air. So here's our after cooler. We may be cooling that with, depending on the size of the engine, with air or an auxiliary system. So as the air comes in, it's going to be cooled down in the after cooler and the temperature is going to drop. So why would we drop the temperature of the compressed air? Well, the idea is exactly the same as before. If we cool the air, it becomes more dense, and again we get more oxygen into the combustion space. So we compress the air to increase the oxygen content, and then we cool it down again, because during compression in the turbocharger the air will become quite hot. So we cool it down, and again we'll increase the amount of oxygen we can put into the combustion space. So we've compressed it, we've cooled it, and then it's delivered into the combustion space. Because we've got more oxygen, we can then deliver more fuel. And when we burn more fuel, we're going to create more exhaust gas. And when we create more exhaust gas, then the turbocharger turbine is going to turn even faster. If the turbocharger turbine turns faster, then we can compress more air. If we compress more air, then we can add more fuel, etc., etc. So this is a feedback loop. We are adding more air, which allows us to burn more fuel, which creates more exhaust gas, which allows us to compress more air. This allows us then to inject more fuel, which gives us more exhaust gas, which makes the turbocharger turbine go even faster, which allows us to compress more air. So it's a feedback loop. And by now you might be wondering, well, what happens when we start the engine? Well, when you initially start the engine, the compressor wheel is turning so slowly that it is almost non-effective. And when you add more fuel, you'll only slowly increase the amount of exhaust gas going to the turbine. It takes a moment for the turbine to really get going once it has the additional exhaust gas. Because of this delay from when you put your foot down up until the point where the turbine starts turning and you can press more air and get more power, this is actually referred to as turbo lag. So that's why you have turbo lag. And when you think about it, it makes sense. Putting your foot down on the accelerator is not going to give you more power. What you need is more fuel and more oxygen, not just more fuel. So in a nutshell, turbo lag equals a delay in response to desired acceleration. In other words, you put your foot down on the accelerator and the response you want is not immediate. And that's what we refer to as turbo lag. So now you know what turbo lag is. Hopefully that's relatively clear. Let's have a talk now about some of the advantages of a turbocharger. The advantages with the turbocharger are that there is increased efficiency. Thermal efficiency increases by up to 15%. So we have an increased overall engine efficiency. We also increase the power output of the engine, and this gives us a higher power to weight ratio. So you have to imagine here we're probably adding less than 5% of the engine's total weight because the turbocharger itself is not very big, but our maximum power output may increase by up to 25%. So it's a combination of the turbocharger's light weight and its ability to drastically increase the engine's power output that increases the engine's overall power to weight ratio. Should also briefly mention that a turbocharger in some respects is very much like a combustion turbine. We have a compressor and we have an air inlet. We compress the air, we then burn it in the combustion space, we then discharge it to a turbine, in this case it would be a gas turbine, then we have exhaust out, and perhaps we have a generator, or maybe we'll even use a combustion turbine for aircraft. So the concept is quite similar. If you like this video, please do share it or like it on social media. It really helps us out and allows us to produce more and more content. And if you want to learn more about diesel engines or internal combustion engines, then check out the link in the video description below. The link is for a combustion engines video course, and if you click on that link, you'll see there are a lot more videos like this one here, and you'll be able to purchase the course at a discount price using that link. Thanks very much for your time.